Okay, we are doing marketing analytics with R. Today we are going to look at another statistical test, which we call the binomial test. Now, binomial test is important when you make marketing decisions, uh, especially if you want to generalize what the entire market thinks about a couple of products. Now, the reason why we are using binomial test is because whenever you are trying to find out uh, anything between two levels of a variable. Uh, so in this case, we are going to take a look at two products. So binomial tests are more appropriate to work on or test on where there is dichotomy, or in other words, where there is a binomial distribution, where there are two levels of test that you want to do. So binomial test is a parametric test, which means that you take a sample and then you calculate the statistics based on the sample, and then you, based on the statistics that you find from the sample, you make decisions about the entire population. Uh, this test is also typically observes proportions. Unlike when you do chi-square test, a test where you find where you try to understand the frequencies, binomial test tries to focus on proportional change. This test uses sample data to determine if the sample proportions are equal to population proportions of binary variables of the specific claimed value that you set. So this test, binomial test, whether the probability falls between 95% confidence interval. Uh, that's the region. If the probability that we are trying to calculate falls within this region, we accept the null hypothesis. If it does not fall within the confidence interval, we reject the null hypothesis. Once again, the p-value that we're going to calibrate or we're going to set for this one is 0.05 as well. So these are the two things that you need to check in a test for you to make decisions about the significance of that test. Okay, one critical function that we use in R when you run the binomial test is the binom.test function that requires actually three arguments: the number of successes, number of trials, and the hypothesis probability of success. So let's look at a context here, marketing context here. Now there are two products, product A and B. Let's say our product and our competitor product, or it could be our own two products, whichever the way is fine for you to think about this context. We administer a kind of a preference survey about these two products, product A and B, with 20 customers, which is going to be our sample size. 12 out of 20, which is 60% of the customers, indicated they prefer product A, while 8 customers out of 20, which is 40% of customers, indicated they prefer product B. Now, the marketing question a marketing manager or the head of marketing would have is the observed value of 60% of customers who preferred product A significantly differ from equal representation. Now, equal representation should be 50% for product A, 50% for product B. And you try to understand in the entire market. So you take a sample, you calculate the sample statistics, and you want to generalize that to the entire market. That's what we're going to do. So once again, since this is a significance test, we have to set the null hypothesis and alternative hypothesis. In this case, I'm going to just share with you only the null hypothesis, because it's always the opposite going to be the alternative hypothesis. So the null hypothesis for this test is going to be the true proportions are equal to 50-50% between product A and B when you compare with the entire market. So let's run this test. How we're going to do this one is I'm going to open R. I have already done that one. I'm going to run binom test. I'm going to check that one. And here, like I said, there are three arguments for this one. These are the arguments: number of successes, number of trials, and hypothesized probability of the success. So let's set that one. So first thing is going to be our number of successes. Since we are going to look at product A, preference of the product A, so we're going to say x equal, that's going to be x equal to 12, which is the, if you can remember, which is the 60% of the total sample population, comma, we use the sample size, the total sample size, which is the n equals 20, total sample size 20. And then we're going to set the probability to be, let's say, 0.5 as our 50% chance. Let's see what it's going to give us. Now, if you run this one, you will see that the probability that we got is 60%, which is little over than that as you look at these two numbers. But we want to see if this is really different. Even though we see this different probability 0.5 that we set the hypothesis probability, and the probability that the test gave us are different. So we need to see, based on the p-value, that's going to be number one we're going to use, if this test is really significant. Based on the p-value technique that we use, the p-value that we have yielded here is 0.50, which is greater than 0.05. So in that case, it says that there's evidence, statistical evidence to accept the null hypothesis. What is our null hypothesis? Our null hypothesis is the true proportions are equal to 50-50 between A and B products in the marketplace. So in other words, this x equals 12 out of 20 sample size, which we said it's closer to 60%, is not actually 60%. It is actually 50% in the larger population. So this test actually accepts, we find evidence to accept the null hypothesis here. The other technique to prove the same argument is the confidence interval. Now you will see the confidence into 95% confidence interval here is between 0.360 and 0.808, so which actually falls within the success probability of success falls probability of success rate actually falls within these two confidence interval range. Therefore, we accept the null hypothesis. That's a second way to second approach to use to establish your argument here. Now, one critical thing I need to share with you: when you say 95% confidence interval, it has nothing to do 95% confidence interval. It has nothing to do with your own confidence that you have. What it actually tells us here is that if you run the same test with the same sample size, with the same expected probability that we set, what happens is, uh, if you run 100 times, 95 times of your test that you conducted, you get this probability of success, which is zero point 0.6, that falls between these two uh, numbers. In other words, the confidence interval range between 0.36 and 0.36 and 0.81. That's what it says. So it is the significant level, confidence level of the test. What about the other 5%? That is the error level. So if it falls beyond the critical point, which is this confidence rate, that falls into the 5% or 0.05%, then in that case, we'll have to reject the null hypothesis. Hope this helps. One other thing that I want to share with you really quick is, if you want to do a range for this one, we can do that one by using a different function, that is d binom, and then we can set a range. Let's say we want to test anywhere between probabilities between 8 and 12, instead of 12. Out of 20 trials, we want to test same p-value. I'm not using this x. I can do that as well. I can do x like I did earlier, and then I can do for this one also n, that is a sample size, and then p is the probability. And if you run this one, okay, what do I get here? X equal, oh, let's take this off actually. Yeah, let's run this one. Yeah, these are the probabilities that you get. So this is at the 8 or number of customers from the sample. If you take 8, this is the probability that you get. If you take 9, this is the probability you get. If you take 10, this is the probability. 11 customers, that's a probability. And if you take 12 customers like we did earlier, that's a probability that you're going to get. Now, probably sometimes you might want to sum this up. You want to see if I do all these sample size, all these customers ranging from 8 to 12, we can sum all these and find out what is the total probability as well by using the sum function. So I'm going to use that one, sum. I'm going to say d binom, and then I'm going to say 8 to 12, comma 20 out of 20 sample size, and then the probability of 50%, 0.5. See, this is the total value. If you add all these that we got earlier, this is where you will end up. So it will come to 74% probability that these customers would say yes or no, or product A or B, or whatever the test that you want to conduct. Hope this helps. I am looking forward to come with another statistical test soon in the next video. Until then, see you later.